Knurling textures don't just add a great grip, they also give your designs that clean, professional, industrial look. Today, I'm going to show you how to build a fully parametric knurled model from scratch. The best part? By simply tweaking a few parameters, you can instantly generate a pen holder of any size and control the knurl density on the fly. Okay, let's dive right in. First, let's look at our design and some key dimensions. We'll input these into the parameter table, which makes it super easy to adjust everything later. Go to the Modify panel and select Change Parameters. Click that plus icon to add our first one, diameter. Let's set the outer diameter to 90 millimeters. Next is height, 100 millimeters. And then wall thickness, we'll set to 2 millimeters. Okay, perfect. Now, to keep things organized, right-click the root directory in the browser and create a new component. Let's rename this to pen holder. Click Create Sketch in the top left and pick the XY plane. Grab the circle tool, snap it to the origin, and just type in diameter for the dimension. That's the base of our holder. Looks good. Let's hit Finish Sketch. Now, I'll hit the shortcut E for the extrude tool, select the circle, and enter height for the distance. And just like that, we have a solid cylinder. Head to the Modify menu, select Shell, click the top face, and type in wall for the thickness. Now we're getting somewhere. Next, grab the chamfer tool from the Modify menu. We're going to select the bottom, outer, and inner edges, along with the top rim. Let's give it a 1 millimeter chamfer and hit OK. This doesn't just make the model look more refined, it also prevents elephant's foot when 3D printing. And there we go, we've nailed the basic modeling in just 4 simple steps. Before we jump in, we need to define 2 more parameters. The first is knurl pitch. This controls the spacing between the lines, which basically determines the texture density. A smaller value means a finer look. In the parameter table, let's create knurl pitch and set it to 5 millimeters. The second one is knurl number, which is the total count of knurling features around the circumference. Let's enter round diameter times pi divided by knurl pitch. We're using the built-in pi constant and the round function here to make sure we always end up with a whole number. And don't forget to set the unit to no units. Since this is a count, it needs to be a pure number. Now, let's get that knurling started. Head to the construct menu and select offset plane. Pick the bottom face and offset it upward by 2 millimeters. This is going to be our starting plane. I like to leave a small gap at the very bottom rather than starting the texture right from the edge. It just gives the final piece a much cleaner, more intentional look. Now, go to the Create menu and select the coil tool. Pick the plane we just created, snap to the origin, and type in diameter. Over in the settings panel, set the height to negative height and subtract 2 millimeters gap at both the top and bottom. For revolutions, let's enter 0.5. You'll see exactly why when we use the mirror tool later. Set the section to internal triangular since we need to cut a sharp V-shaped groove into the surface. Finally, set the section size to 1 millimeter and make sure the operation is set to cut. Perfect, hit OK. Now, let's wrap this operation around the entire circumference. Head to the Create menu, go to Pattern, and select Circular Pattern. In the settings, make sure to set the object type to Features, then click the coil icon in the timeline at the bottom. For the axis, just select the bottom outer edge of the cylinder, and for quantity, enter knurl number. For the compute type, go with identical. While optimized is the fastest, it can glitch on complex surfaces. On the other hand, adjust is precise but very slow because it recalculates every intersection. We'll choose identical since it's fast and stable for a standard cylinder like this. Now, the final step. Head to the Create panel and select Mirror. Keep the object type as Features and grab both the coil and the circular pattern from your timeline. For the mirror plane, go to the origin folder and pick the XZ plane. Actually, the YZ plane works just as well. Hit OK, and there it is, a perfect parametric knurling. To get a fast print, I'm jumping back into the parameter table. Let's shrink the dimensions and the wall thickness, but keep the knurling size exactly the same. There we go. You can see the holder scaling down, while the knurl texture keeps its original size. This is definitely one of those I love parametric design moments. This model and the Fusion 360F 3D source file are available on MakerWorld. you are welcome to download and check the source file. Through this file, you can clearly see every step of the modeling and the parameters I've used. And through the parameters table under the Modify panel, you can easily modify these parameters and customize the dimensions. Okay, send to print. Now, let's check out the final results. I'm really happy with this texture. It's clean and precise. Compared to a smooth surface, this has a much more premium feel and provides extra grip. I mean, not that you really need a high-performance non-slip pen holder, but hey, why not? Okay, if you found this tutorial helpful, please hit the like button and subscribe for more 3D printing designs. Let me know in the comments what should I model next. Thanks for watching, and I'll see you in the next one.